Just as in contextual pre-filtering, the contextual post-filtering algorithm begins with our initial user by item multidimensional context tensor containing ratings. However, notice here, we are sending our initial data directly to our traditional two-dimensional recommendation system. How can this be? Why did we not apply the context filter before the recommender? What happens to all the context dimensions? Well, we simply ignore them. We ignore context. We process the data as if it was just a user-item interaction matrix. This is good in the respect that we can use our traditional collaborative filtering technology, but aren't the recommendations going to be the same as if we never had the context data to begin with? Let's wait and see to find out. We then apply our user's vector to the output embeddings to get the representation in embedding space. This gives us our recommendations. But these are exactly the same as if we never had context data. Because in machine learning, it is such a shame to throw out possibly good data, how do we fix this problem? Well, we can try to adjust our non-contextual recommendations by applying the context back in. As you can see, this happens after the recommender, hence it is called contextual post-filtering. This can be done by filtering out recommendations that don't match the current context, or altering the ranking of the predictions or recommendations returned by the recommender. These adjustments can be determined using either heuristic or model-based approaches. For example, if our user from before still wants to see a movie on Thursday after work, and on Thursday they usually watch action movies, our post-filtering can filter out all non-action movies from the recommendations, returned by our non-contextual recommender. This then gets us finally to the contextual recommendations that we wanted. Contextual post-filtering has several methods, of which weight and filter are the most popular, and are based on adjusting the non-contextual recommendations based on the context's relevance to the user. To find this relevance, the contextual probability is calculated for user I, choosing item J, in context C. This is calculated by dividing the number of users similar to user I, who chose the same item J in the same context C, by the total number of users similar to user I. The weight method multiplies the non-contextualized ratings by the contextual probability to get the adjusted contextualized ratings. The filter method, on the other hand, filters out predicted ratings below a certain threshold value of the contextual probability.